we are going to talk about intermediate Git today, and I know it's a pretty lousy title. Unfortunately, I cannot come up with something more creative than this. At least, hopefully, what it suggests is this is not Git 101. This is looking into some of the features that Git offers you that can improve your workflow, that can prevent you from getting in a situation where you're working on A, you have to shift to B. How do you easily switch between contexts? We'll see some of the advanced features of Git, like rebasing interactively. We will see Git reflog, Git stash. We will see good habits when working with Git. So another title of this talk could be Git tips and tricks, essentially. Now, like most tips and tricks talks you might have seen or heard or given, they can be a little choppy because there's no overarching narrative that I can provide you that goes from one point to the next. So for that, I apologize upfront. With that said, does anyone have any questions about what they're going to see in this talk? Is there anyone here with a specific agenda? You want a question answered? You want something specific you're looking for? Yes, sir. I do not cover tags, but we can talk about tags right after this if you want. What about conflicts? You mean conflict resolution? I don't cover that, but the thing is, there's not much to cover. Git, the nice thing about Git is it's truly a stupid content tracker. It does nothing smart with conflict resolution. So you have left hand and right hand side, and you figure out which side you want to keep. I can show you, let's see if we have some time, I'll show you maybe a trick or two which will help you with conflict resolution, especially, I'm assuming your conflict resolutions are coming as a result of a merge. Yes, I can show you some tricks with that. So just remind me around an hour into the game and maybe I'll cover that. Yes?
So we are in the process of migrating from Tfs to Git.
From what to Git? You have my apologies.
Think of any tips that would be useful for us in this country.
Okay, why don't you catch me after the session? That's a much longer discussion, but I'll catch me after the session. Sir?
It'd be nice to talk about tools, GitK versus KDiff, and the different tools that are available. GitK is very common, but there are a lot of nice GUI managers. Or is Bash just the best environment for managing that type of issue?
So I'll take that up front. The answer is the command line is your best interface. And you should use the command line because it gives you the basis to understand Git. If you want a suggestion from me as to what GUI-ish tool you should use, it's called SourceTree. It's from Atlassian, it's free, and it's got, I do very, very extensive work with Git. So it doesn't cover 40% of my use cases. But for the normal user, switching branches, merging, pushing up, pulling down, 90% of use cases covered. You can even stage incrementally, like you can take a line from a file. Let's say you change 50 lines, but you only want to stage 5 lines. You can select those 5 lines, say stage only these 5 lines. And that's called incrementally staging. And you can do that in SourceTree. So for most users of Git, 90 to 95% of your use cases are covered. So my suggestion, just run with it. It's free, it runs on every platform, and it works. And their implementation is actually pretty good. How many Eclipse users in the room? Any Eclipse users in the room? Do you guys use Git from Eclipse? Good. Stop. You need to stop. It is a bad idea, right? And I'll tell you why. Because the eGit implementation has not caught up with Git. There are lots of things that come in Git that do not work in eGit. You need to stop. Pick something else. Use SourceTree if you want a GUI. Do not use the Eclipse implementation. It is a bad idea. Yes, sir.
First of all, yeah, SourceTree rocks.
There you go.
Thumbs up there for anything that you can't do in the command. Boring stuff. But I did have a question. Like, I know you're planning on covering like rebase and interactive rebase. Like, is there any ways that you can use those sort of commands when you're working on? Like, are there any ways to rebase a branch and like deal with that when you have other people who may have pulled it down?
No. And the rule of thumb is if you rebase and it is a public commit. Okay, let me take a step back. If it's a public commit, as in you've already pushed upstream, never, ever, 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 ever rebase. It is a bad idea. Unless something really bad has happened and you need to fix. At that point, everybody has to check in their code. You rebase, you push force upstream, everybody catches up with origin again. There is no other way to work around that problem. Just because of the way Git works, fundamentally. I've done that. I've done surgery on Git repositories after the fact, but there is everybody check in on Thursday evening because come Friday morning, you're probably either going to have to clone again or do a reset hard on origin, whatever branch you're working on.
Like, because I would we use Git flow, and like sometimes like I have a feature branch and I'll rebase and it's developed to kind of clean up the history a little bit. But then I mean I'm like, okay, everybody delete your whole branch and let's just pull layers if there's no other way to deal with it.
Nope. Collaborative branches don't rebase, and if you do, you have that problem. Alright, so we already covered a few tips. Good start. Allow me to introduce myself. You might have caught my name off the schedule. I'm Raju. I'm loosely typed on Twitter. My apologies for the colors. We are having technical issues today. Now, usually for my technical talks, I have two disclaimers. The first one is sometimes I get really, really excited and I speak really, really fast. If you have any Indian friends, you might have noticed this phenomena at work. The second one is very subtle. Now, I don't think I have an accent, but you might disagree. If I say something and you don't understand what I just said, just raise your hand, I'll rephrase, right? It's not a problem, happens all the time. Let's get started. Just recap. If you've done any kind of Git work up until now, commits are your level of abstraction. The level of abstraction you work with, the most atomic level, is the commit. A commit actually is far more comprehensive than meets the eye. When you have a commit references something called a tree. A tree is the state of your working directory as it was when you made the commit. So let's say your working directory was a root level with one file in it. What does a tree look like? Root directory with one file, right? So there is a tree that the commit points to. Every time you have subsequent commits, so you have the initial commit, after that you make a second commit, a third commit, each commit has a pointer to its parent. If you have a merge commit, and I'll show you a picture in a second, it can have more than one parent. There is the author info and timestamp, and then there is a commit message body. This is what actually makes up the commit in Git. This is what the tree looks like. This is what a commit will look like. So the tree has a hash attached to it, which uniquely identifies that listing of files. There is the parent SHA's commit, my author info, my committer info, and some message. For the people standing in the back, there are some seats in the front if you would like to come up to the front of the classroom. Unless you're the guys who sit at the back. So this is how your typical graph would look like. This is called the directed acyclic graph in Git. So for every commit, you have something like this that it points to. This is a commit. Time goes forward up. So you make the initial commit, second commit, third commit. Each commit points to a tree. The tree can point to files or other subfolders that point to files. Does that make sense? Each commit points to its parent. This red, whatever this orange color that you see over here, this is called the directed acyclic graph of Git commits. It's called directed because children point to parents, but parents don't point to children, which makes it acyclic, and graph because there are red circles with arrows pointing on them, right? So directed acyclic graph. Now, you have to keep that diagram in mind as we go forward. When I talk about rebase, that will become important. Let's talk about the ref log. Anytime you're working with Git, when you switch branches, what happens? When you switch branch from master to some other branch, what happens? Head changes. The head pointer changes. There is something that Git maintains under the cover called a ref log. It is called a reference log, which is essentially a list or a log of any time head moved around. So, I have here, can everyone read that from the back? Is that big enough? Excellent. What I have here is just a directory I created. It's got 2 files in it. And the git log, let me make that a little bit more subtle. Git lg. So as you can see, my directed acyclic graph has 2 commits. This is the first commit. This is the second commit. Now, if I were to create a branch over here, git branch some other branch, and I were to do a git checkout some other branch, and then I look at git ref log, you notice that when I made my first commit, head moved from no state to the first state. Then the second commit moved the head 1 up. And now that I'm switching from master to some other branch, I see a third entry. This is the path you took to get to wherever you are right now. The nice thing about the ref log is that, for example, let's say I go back to master and I delete git branch delete some other branch, and you say, oh dang it, shouldn't have done that, I want that branch back. What do? Git ref log. Notice that it told me I'm moving from master to some other branch, and I moved from some other branch to master. This is the commit that I was on when I switched back to master, right? So now I can simply do git branch, call it some other branch, give it the SHA I want to base it on, and I'm back to where I was. So the nice thing about the reference log is that anytime you switch, it keeps a log of where you were and where you went to. So if you reset by mistake, you can always go back to where you were. If you switch branches and delete a branch, you can always go back to. Does that make sense to everyone? Now, a couple of things to note about the reference log. The reference log is local to your machine. It does not get shared. When you do a git push upstream, the reference log does not go. What is the only thing that goes when you do a git push upstream? The directed acyclic graph. Those red dots I showed you, and everything attached to those red dots goes up. The reference log does not go up. The nice thing about the reference log is if your company uses a central Git server, for example, you use enterprise GitHub, or you have a Git repository that is your source of truth, right? And someone does a git push force on that. If they do that, first of all, you need to have a talk with them. That said, the reference log on the server will tell you where head was before someone did a push force. So all you do is go back to where you were, reset the repository, and everyone's in a good state again. And I can assure you, the experience I've had with Git, there have been way too many times I have spent with GitHub's reference log. I've actually emailed GitHub and said, I need this reference log emailed to me pronto, because someone just pushed forced on my server. So the reference log is your friend. The reference log is your safety net. Anytime you switch, anytime you reset, anytime you delete something, if you can get it back. Now, if you delete a branch in Git and there is nobody else referencing those commits, after 30 days they get garbage collected. So don't think the reference log will save you 2 years from now. The reference log is something that you can use immediately. Therefore, here's this was a thing I just captured quickly to show you what the ref log will look like. Another thing you see here is this head at 90, which is just another way to reference a particular hash. So if I go back here and I do git ref log, let's say I want to check out this commit. I don't have to copy paste that. I can simply say git checkout, checkout head at 2. And now I'm in detached head state. Notice that my head has got this checked out. So you don't have to put a SHA. If you know I was here, I made a mistake, and I already made 2 commits, I want to go back 2 commits, you simply say head at 2, and boom, you go back in time to 2 head movements back. Does that make sense to everyone? The thing to take away from here is keep calm and use reflog, right? Reflog is your friend and very, very useful. How many people knew about reflog before they walked in this room? Good. Use it. It is your friend. Well, again, that's only if you delete a branch and won't get it back. Otherwise, the reflog will go in hundreds of entries, and you can go back in 3 weeks in time and say, where was I at this point? Let's talk about my best friend, Rebase. This is the Swiss Army knife of Git. This is the tool that can change the way you perceive Git. Anything that you think you want to do with Git, you can do with Git with one simple command, the rebase. Extremely powerful. The one we are going to explore is Git Rebase Interactive. But before we go into that, let's recap and make sure we understand what rebase is. How many people truly understand what rebase is, or think they truly understand what rebase is? 1 hand, 2 hands. Most people are comfortable with rebase. Let me ask you a question. In this state of affairs, if I were to go on master and say git merge new feature, or right now I am on new feature, so let's just say git merge master, what were to happen? Right. And what you will get is a new commit up here that points to him, and he is the resultant of adding these 2 commits together. The 2 deltas come together, right? So when I talk about merge, the analogy I provide is marriage. 2 people come together and produce a child. It's marriage, right? Merging is marriage. What is rebase? Rebase is relocation. You move from where you are right now to some other place. Think about it that way. If this is the state of affairs, I have an initial commit, second commit, and at this point, master and new feature have diverged in history. If I rebase myself on top of master, notice what happened. What happened is I had this commit over here that was based on this commit, right? What rebase does is, if you say rebase me on some other commit, it says I'm going to take that commit or whatever series of commits were attached to it, and I'm going to relocate it on top of some other commit. Another way to think about this is, if you look at this chronologically, which, by the way, for those who are kind of new to Git, time is of no meaning in Git. There is no meaning of time. People say, did this commit come before that commit? That question can never be answered. Just FYI. But chronologically, let's say this commit happened, this commit happened. He started working on master and he made this commit. I started working on new feature branch and I made this commit, right? So we are both working simultaneously. What is rebase doing? What rebase is doing, saying Raju never started working when this commit happened. Raju started working after he finished his work. So it literally takes all the changes I made and applies them on top of his changes. Does that kind of make sense? It's relocating where my work started. My work started here, but with a rebase, I can pretend I started working after he did. Now, let me take another step back. Everyone understands merge, right? So let's say I started the repository with a file called a.txt. Just one file, a.txt. In this commit, I added a second file, b.txt. How many files are there in the repository right now? 2. A and B, right? I built the second commit on the first commit. So I have 2 files. He started working on master. He added a file called 1.txt. So how many files are there in his repository, in his clone of the repository? 3. I started working and I added a file called 2.txt. How many files are there in my copy? 3. A, B, 2. Now, if I were to merge the 2 commits, how many files will there be in the merge? 4. A, B, 1, 2. Everyone agree with this? Now, let's go back to a.txt, b.txt, 1.txt, 2.txt. I'm saying the rebase pretends I started working after he finished his work. So at this point, how many files are there? 3. I created a new file, but I pretend I created the file after he created his file. How many files are there in this commit? 4. A rebase is no different than a merge. There is no difference. Whatever result the final commit sees as part of a merge is what you will see if it was a rebase. Does that make sense to everyone? And most people will argue with this. Oh, that probably is not right. No, it's right. Guaranteed. Under the cover, there is a merge happening. The difference is how the history looks. What does this look like to you? It's one straight line. It's one linear line. Versus a merge would have done what? Would have created that funky triangle that you see in your Git histories. Right? When 2 branches come together, what happens? You get that funky triangle. So the only difference between rebase and merge is they're both doing a merge under the covers. The only question is, how does the history look after you are done? In a merge, you get the triangle. Well, potentially get a triangle unless it's a fast forward merge. Otherwise, you will, in rebase, you get this straight line. Some people like straight lines, some people like triangles. Right? Now, there are other ramifications to rebase, but this is the 101 on rebase. Yes, sir.
Isn't this case only when you add new files, but if you change the content of an existing file which the previous person worked on, in this case you're going to have conflict?
What did I tell you? Someone will argue with that.
The answer is you will still, on a rebase, you can get a merge conflict. Now let's go back and say, take your example. A.txt, b.txt. He changes b.txt and I also change b.txt at the same line. Same line. When you merge, what happens? You get a merge conflict, right? If in this case, I had rebased my commit on top of his commit, the rebase will stop and say you have a merge conflict, resolve the merge conflict. The final commit will be identical. Guaranteed. You will get a merge conflict. Yep. Now the whole point of this isn't to discuss rebase. The whole point of this is to rebase interactively. Now if this section, the point of showing you this portion of the talk isn't so that on Monday you start interactively rebasing all your commits. That is probably a bad idea. And the reason I say that is if you don't understand how rebase works, it will bite you. What I want to show you is the sheer power of Git. Show you what is capable of if you're willing to spend the time and effort to understand Git. Rebase interactively lets you rebase commits. So what I'm going to do here, I'm going to git checkout master again. So I'm back in a good state. I'm going to, let's see, we have 2 files here. Let's create a branch. I'm going to call it a feature branch because my boss came to me and said, we need a new feature out there. I am going to touch, what do I feel like writing today? Let's write closure code. Sure, why not? CLJ. So I'm going to touch a CLJ file and I'm going to open it up. So let's write our first method. Now what we write here doesn't matter, so we are going to write the world famous hello world program. Let's do this, set syntax closure. Okay. And he takes a message, or he takes a 2, and I simply return hello world 2. This is just a method that says hello world in closure, doesn't matter. Save the file. There you go. Save, replace. Okay. We are going to git add test.clj file, and I am going to make my first commit first. So everyone with me so far? This is what the commit history looks like. Uh-oh, I'm on the wrong branch, aren't I? Okay. What are we going to do? How do we fix this problem? Yeah, it's right. Rebase. What I'm going to do is git reset soft, and you can ignore this discussion for a second. Head down, git st, git co feature branch, git st, git add test.clj, git commit first commit on feature. Nice to have a flag there. Yeah, okay, and then what I'm going to do is I'm going to delete some other branch. -d some other branch. Alright, everyone good with this? So I made a commit on the branch. Now what I'm going to say is, oh crap, man, I forgot to put a comment here. Let's put a comment, says hello world. Right? I'm going to git ci commit -am added comment. Right? Now I'm going to add 2 more methods. Defn say goodbye 2 str goodbye 2 and defn whatever blah, doesn't matter. I'm adding 2 methods. Boolean, okay, where did that come from? Blah and str yada. Anyone a Seinfeld fan? Yada yada yada. Alright. So git st, sorry, forgive me, I shouldn't use my aliases. Status. Right. Git status shows me that. Git commit -am second commit. Alright. Ooh, crap. I should have written my tests. Let's write a test real quick. I'm just going to put test method over here. And this could be a separate file, the same file, doesn't matter. The point is I'm just going to create commits. So test hello and is equals hello Raju. Hello. Okay, so we wrote a test. Git ci dash git commit -am added test, right? And let's just make one more change. I forgot to add a comment here, so add comment and git commit -am add comment. How's everyone doing? We have 4 commits. My feature branch is 1, 2, 3, 4, 5 commits ahead on master. Right? Now I'm thinking, I'm going to Git Rebase Interactively this. So what I'm going to say is rebase this branch on the master branch interactively. Now let me show you what that does before Git. Sure, sounds like a great time to update. Git rebase. Oh, I forgot. Oh, let's do Git rebase interactively on master. If I do this, notice that Git comes up with this pop-up. All the 5 commits that are there post master are listed. Now, what can I do over here? Well, if you read the documentation down below, it says you can do a bunch of stuff. I can pick commits, I can squash them, I can edit them, I can reword them. Let's do a simple one. What I'm going to do is I am going, notice there's one called reword. Notice I typoed this comment, right? So I'm going to say reword. I'm going to save the file. I'm going to get out of the editor and notice Git is now rebasing. It hit that commit and stopped rebasing. And it said, you want to reword that message? Go ahead. So if I change this message, and do a git, notice the last one is now corrected. This is why my colleagues don't know how many times I screw up. Because before I merge any branch into this, or I merge this branch into anywhere else, I rebase interactively to fix problems. Now, I did the first commit on feature and then I added the comment. I don't want my colleagues to know I forgot to add the comment, right? So I'm talking about these two, right? These two guys. I added the feature and then, oh man, I forgot to add that comment, so I'm going to add a comment now. What can I do? Well, before we do anything, let's go back to the state of affairs we were on before we started this entire experiment. What do? Git reflog. What does it tell me? It said I started the interactive rebase at this point. So this is the commit I'm interested in. So I copy that. I check out master. I delete feature branch. I create a new branch called feature branch. Off of that SHA, I do a git LOLA. Notice I'm back to where I was with the bad comment. I'm just resetting it so that we can start the experiment all over again. But do you see the power of reflog? That's the nice thing, is I can go back to a state prior to making big changes. Let's do a Git Rebase Interactive again. I get the pop-up. Uh-oh, what happened here? Oh, thank you. Git CO feature branch. Thank you. Rebase Interactive master. I don't want people to know I forgot this comment. So what I'm going to do is I am going to squash that commit. Notice what it says. Use commit but meld into the previous commit. What that means is take whatever changes came here and make them a part of, I'm sorry, that's not the one I want. This is the one I want. So squash means take whatever changes happened here and meld them into this guy. So save, close out. This is a combination of two. This is Git coming back and saying your first commit had this comment, your second commit had this comment. I don't want my fellow developers to know I forgot the comment. So kill all that. Don't want it. Save. Now if I do a git lola, notice that first commit and then you see second commit. But if you look at the file, notice that the comment is still there. No one knew I forgot to add the comment. Does that make sense? Let me show you one more. Git co master. Git delete the feature branch. Create the new feature branch. Check out the feature branch. And I'm back to where I started. Let's repeat the whole experiment. I am going to now Git Rebase Interactively on master. Now, if you remember this second commit that I added two methods at the same time. Right? I don't want my developers to know I'm making really big commits. I want to splice that commit open into two parts. Right? I don't want one commit there, I want two commits there. So what I'm going to say is, hey, Git, please help me edit this commit. I'm going to save the file. Notice that it stopped at that commit. Stopped at that commit. You are at the second commit. If you see the file as it looks, it is the state of affairs it was at that commit. Notice the two methods I added, say goodbye and blah. So what I'm going to do, and here's where the trickery comes in, git status is on rebase, but working directory is clean. Git reset soft head to its parent. Git status now shows me that file is modified but staged. Git reset head test.clj. Now that file is checked out. I go in here, I cut out this method, I save the file, I git commit -am add say goodbye. I put that method back. I make another commit which says add blah. I say git rebase continue. And if I do a git lola, notice that that thing is now spliced up into two commits. So you can meld two commits together. You can take a commit and break it open into two commits. You can do whatever you want. In fact, and we are back to where we started the experiment. I'm going to git rebase interactively again on master. And you know what? I don't even like this commit. I don't know what I was thinking when I wrote it. Delete that line, save the file, close it, and now if you see, that commit's gone. So let's say you made 15 commits, but there was one commit you're not particularly proud of. Throw it away. Just delete that line in the interactive rebase. It will never show up in the history. Do you see the power of this? In fact, you can even run shell commands against each commit as the rebase moves forward. So let's say in the first commit, in this first commit, I stored my user credentials in a file. What do I do now? Well, I can literally go in and say git edit that commit with a sed command or an awk command, replace the text with something, make a new commit, recreate everything else. That is the power of rebase. Now, granted, perhaps you lost me when I did some of the git editing, and that's fine. The point I'm trying to make here is this is worth learning. The power of rebase will change how you work with Git. It is really that powerful. How's everyone doing so far? Who's impressed? Who hates my guts? So that's Rebase Interactive. The I flag is what you want. And you can give it any commit. It doesn't matter. You can rebase off of any commit. The point is you're rewriting history. You're relocating to that new point. But while you relocate, it's kind of like moving houses, right? You move from location A to location B, but while you do that, you change furniture, you get new curtains, and then you move, right? Most people don't just move, right? There's usually some furniture expenses that come with that. That's what Rebase Interactive is. It allows you to not only move locations, but change things before you move. Lousy analogy, but the point still stands. So this is all you can do. We did pick, we did revert, we did edit, we did squash. You can exec, which is what I was telling you, is run a command against that commit using a shell script. And this is what I was showing you right now, is I can keep rewriting these commits over and over again by a Git Rebase Interactive. My head is here, so 1, 2, 3. Head tilde 3 will rebase me again and again on this commit. So after I'm done with the Rebase Interactive, will the graph change? No. Remember, I'm relocating to this location again and again. If I had said Git Rebase Master, right, what am I saying? Move this guy on top of this guy. But I'm here saying Git rebase me again and again over here. So Git rewrites the commits but keeps my parent pointer here. And I do this all the time. Clean up commits, go back. Clean up commits, go back. So the point of this section being, go look at Git Rebase. Go look at Git Rebase Interactive. Let's talk about Stash. You are hacking. Oh no, production bug. Your Git status is dirty. What do? Well, what's that? You can't switch, because if you have a dirty working directory and the other branch has modifications to those files, Git will say you can't switch. Please either commit your files or stage your files. You commit it, right? But now you have a commit you may not necessarily like unless you're going to Git Rebase Interactive or reset when you come back, right? Keep calm and use Stash. What that does, is Git status, Git stash, Git status, working directory clean. What it does essentially is it takes all the files that you've modified, including the ones you've staged, creates a new commit out of it, but does not make that commit a part of your Git log. So let me show you how that works. I'm working on this directory. What is my Git status? Nothing. So I'm going to start hacking. So say hello world. Woohoo. Goodbye. Screw you, man. This is being recorded. Yada yada yada, right? And then my boss comes to me and says, dude, production bug, go fix it. I'm like, oh crap, Git status, shit. So what do? Git stash. And now Git status clean. I can switch branches, I can do whatever I want. My log, Git LOLA. Notice my log actually shows you how that guy participates in the directed acyclic graph. It does not show up in the history. If I push this upstream, no one will see that stash. However, it is a commit. However, anything you can do with a commit, you can do with a stash. But it does not participate in the log. If I push this up, no one knows it existed. What can I do with this? Well, I go back to master. I do hack. I come back to, and I say git stash list. And notice it says I have one stashed object. Just to prove beyond reasonable doubt that this is a commit, there's a command called git cat file -t, and I can say stash at 0. Notice it says commit. It is a type of commit. It is a commit object, as everything a commit object has. Now I can do git stash pop, and notice my file is back to screw you man, hello world. And I'm back to where I was in the exact same state. So the stash is a nice way to save your changes without having to make a commit. Now, it depends on how purest of a Git user you are. The truly pure Git users will commit. But then you need to know how to do a safe reset or a safe rebase, right? Because you don't want that commit. It's some working state that you saved so you wouldn't lose it. Stash is a nice beginner tool. Stash everything, come back and use it. Yes, sir?
Do you have any tricks for dealing with untracked files? So if you made some changes and you added a new file and you stash, it won't stash that untracked file.
So if you look at Git Stash Help, I think there is a, man, this font is really big. Hold on, let me make this so small. So options, oh, I gotta pass it. Save, patch, key, include untracked. So, right, I'm sorry, I apologize. It's right. That's what you're looking for? Yes. Yep. And that's actually a good point. So, because it's a commit, right, it's like a commit. Remember when you do git commit -am all flag, what does the all flag apply to? Right. So it's adding all the files to the staging area, right? That's essentially what you're looking for, is include untracked. How's everyone doing with this? The stash makes sense. The nice thing about the stash is it is, let me make this a bit bigger again. So, sorry about that, please. It's almost like every conference center like will spend like millions of dollars on chairs for the projector. Oh no, let's keep that at 768 projection. Man, I should stop talking. This is so let's go back. I'm in a working state, right? Yes. Okay. So let's do a git stash. Oh, I'm sorry about that. How's that? Better? Okay. So git stash. Now my working directory is clean. Let's say so notice everything went away. Let's change some more stuff. Da 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 da. Blah 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 blah. Blah blah. Okay. What's my git status? Ooh, dirty again. Let's stash again. Working directory is clean. If I do a git stash list, now I have two stashes. The first state that I saved and the second state that I saved. So the nice thing about this, you can experiment. You work something, work a new feature in, write some algorithm, try it, does it work? Yep, stash it. Try something else, does that work? Stash it. Now, you think the second one sucks. I want the first one. How do you get it? Git stash. You can do apply or pop. I'll show you the difference in 1 second. But pop. Or git stash, I think apply, and make sure that did, yeah, so screw you man, da da da, yep. So you can go to any stash you want, just stash at curly brackets number, boom, you're back. Does anyone see that pattern before? Remember the ref log? What was that? It was head at some number, stashes have the same syntax, stash at some number. You can get to any stash position you want. The difference between stash apply I did, what did I do just now? I did a git stash apply. The difference between git stash apply and pop is this. Git stash list is, I still have 2 stashes, right? Now let's do a git, what's my status right now? Am I dirty? Yes, I am. Git reset. Let's go back to a clean state. Git status. Okay. If I do a git stash pop, right, it does the exact same thing. The only difference is if you look at the git stash list now, there's only 1 stash left. So a pop is literally like a linked list pop. Take that item off the list and bring it here, but it disappears from this side. The stash apply applies the number you told it to apply, but keeps everything on that list. Another thing I like to do a lot is this. Git stash save some message. And now, if you do a git stash list, notice that that message shows up. My recommendation, put a message if you're stashing. Algorithm 1 or implementation 1. Something that tells you what that stash is about. Right? Because there are times when I have like 30 stashes and I'm like, which is the one I wanted again? Message helps. You can diff. You can diff. Yeah, let me show you what I did there. So I'm saying, show me the difference between that stash and my current state. Why? Because it's a commit. There's no difference. Anything you can do with a commit, you can do with a stash. Given my current head state and the stash, I can diff. I can create a patch out of this if I want. I can do anything I want, just like you can do with a commit. How's everyone doing with this?
Can you diff 2 stashes without bringing it in? Oh, okay, gotcha.
You can do dot dot. You can do dot dot dot. I mean, dot dot and diff are the same. Yes, sir.
So the pop just doesn't show up in the log. It still exists because you did stash on 1, which didn't show up in the stash list, right?
Okay, what's your question?
Oh, okay. I was confused because I thought you popped it. You just said you popped the list. Give it back.
I may create another one. I created the some message one. If I pop the first one, git stash pop, right? And then do a git stash list. There's only 1 left. So when you pop it out, it takes it off the top of the stack. Whatever you're popping, and then drops it on the working directory, but takes it off that list. So you lose that stash. So, I mean, the point is it's just a nice interface to work with. So, it stores the index in the working tree state and it resets the current commit, your head, right? So, whatever your working changes are, get put away on the stash. Basically, you're going back to it's like a reset hard to the previous state. How's everyone feeling so far? Good? Alright, so it's just like a commit, but it does not participate in the log. When I say the log, I mean the DAG, the directed acyclic graph, which means that you push, no one else sees those stashes. They never go upstream because they are not part of the log. Git stash save, git stash list, git stash pop, git stash apply. These are the 2 ones that you want. Right. You can always do a git stash clear, which throws away the entire linked list of stashes. Start afresh. I learned this trick from a book. What this guy's got, he's got a cron job running on his machine that goes to the current working directory and does git stash and git stash apply every 15 minutes. What does that do? Whatever your working state is, it stashes it and immediately restores it. So it puts it on the stack, but then applies those changes back to the working directory. So do I see any change in my working directory? No. But what happened on the stash? I've got a backup copy every 15 minutes getting created. And then it's pretty kind of cool. And then at the end of the day, he just does git stash clear and goes home. So what I tell people, Git is the new undo. You should never undo. right? Either reset hard or git stash pop and boom, you're back exactly where you were 5 minutes, 10 minutes, 15 minutes ago. How many people create like one Git repository on their machine every week? I do. It's insane. Like I'm writing an email and I'll git into the directory and like save the email in there. Ridiculous. Let's talk about workflows. So the one problem with Git is this. I'm going to throw away everything. So just trash the Git directory. Right? So I still have my files, obviously. I'm going to git init. Right? If I do a git status, that works. If I do a git log, if I do a git branch, blah, can't do anything till you have the first commit. Right? Can't do anything. So my suggestion is to create an empty initial commit. And this is how I initialize all of my repositories. The first commit in my repository is an empty commit. It is ground zero. We are computer scientists. How do we start counting? 0, not from 1. So what I do is the init, blah, 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 blah. Okay. Instead, here's what I do. I do that. I do a git commit. I'm not adding any files. I'm not doing anything. All I do is a git commit, allow an empty commit with some message. So if you see here, git commit empty -m empty. Remember, I've not added anything yet. If I look at my git status, still 3 working files. Nothing has changed, but git log works, git branch works. The other thing about having a ground zero commit is, let's say you start working on master and you have to rebase interactively. It's not easy to do if your first commit already has crap in it. This buys me that point where I can pivot off to rebase. Another thing it will help you is if you ever decide to merge 2 repositories together, this is nice because they both have ground zero commits. Merging them becomes easier. Has anyone ever merged 2 Git repositories together? Yeah, I'll skip that discussion. Okay. In fact, I use it so much that I have an alias configured called git start. And what git start does is it invokes this command. So if you just literally copy paste this into your terminal and hit enter, you will now have a new git alias called git start. So I never do git init. The minute I create an directory to write an email in, git start, enter, boom, I get an empty commit. I can start working off of that. You're doing okay so far? Make sense? There is something called Git archaeology, which is basically going back to some of the questions she had about Tfs migrations. I've done repository migration from CVS to Git. I've taken big Git repositories and split them into smaller Git repositories. I've taken small Git repositories and merged them into big repositories. All of that is easier if you have ground zero to work off of. The other thing, what I do is when I bring a CVS repository to Git, right, I migrate. After the migration is over, you verify all the commits are there, all the logs are correct. Then the first thing I do is I make an empty commit at the very top, which is the baseline. Everything before this was CVS, that came from CVS. Now let's start afresh in Git. Just so. The allow empty is kind of useful. Every once in a while, you might have Jenkins jobs that monitor your master branch. Does anyone have that? Master verification. Every once in a while, Jenkins will topple over. Can't get to Git, can't run this command. How do you make it run again? So what you do is you push an empty commit to master. That will re-trigger Jenkins to start the next build. We are seeing a lot of these lately. For some reason, our CI infrastructure can't keep up with the work we are doing. And so it's like every 10th commit is trigger CI, whatever, but it works. How many people use Git hooks in their room? Any Git hook users? Good for you, good for you. My suggestion, right off the bat, the Git hooks directory has a listing of Git hooks. This pre-commit sample, if you rename it to pre-commit and change it to an executable file, is a very, very good, nice use case to use Git hooks. What this guy does is he makes sure that there are no white space that are trailing at end of lines, right? And no white space trailing at the bottom of the file. So it strips out all unnecessary white space, which is a nice, nice hook to use, right? Yes, sir. Oh, I'm sorry. What is a hook? Take a step back. A hook is something that fires at a certain point in a commit or a workflow life cycle. So a pre-commit hook, whatever script you put in here, will execute before Git records a commit. Pre-push will kick in when you do a git push origin master. Just before that push activates, this hook will fire. This could be any kind of script. Doesn't have to be a shell script. It can be a Groovy script. It can be a Ruby script. Doesn't matter. As long as you have the right environment, right? You can do Ruby some name. These scripts will fire. They are in your .git directory. So if you go into your working directory in your repository and look under the hooks directory, there's a listing of these.
Do these samples reflect all the different events that you can hook, or
Yes.
is this just a sample?
No, this is all of it.
Okay.
Now, the one thing to bear in mind, these are local to your repository. So if you want these hooks to be shared by everyone, you have to share that hook and tell your developer, dude, copy this file in the Git hooks directory. Let's say you write your own hook. You have to send it to him by email or whatever and say, drop this in this folder. It's not shared by Git push and Git pull. It's only for your machine.
So the Git directory is the one under the default location.
No, it's like if I initialize a Git repository here, per repository, yes. Yep, so right there. And if you do tree.git hooks, there's the list.
Okay.
One thing on those hooks, it works good for us. Create a symbolic link to something that is in your repo. That way, your developers only have to set those up once. You can version control your post.
Ah, so that's a good point. So that's a good point. So what he's suggesting is in your main folder, right, in your actual project folder, make the script files and then tell everyone symlink these files to those files. So you can change those files and the symlink will update automatically. So you can version control your symlinks. What we do is we actually have initialization scripts for Git repositories. So when you clone a repository, the shell script automatically fires and updates everything and does everything correctly, depending on however you do it. This is a good start. Like I said, it checks for trailing white space. Look at it. Lots of people use this for lots of things. You can spell check your documentation. You can ensure that the code compiles. How many people have had developers on their team who pushed code up to master that didn't even compile? Was that you? That may be a little excessive, but if you have those kind of problems, the pre-push should say JavaC blah or whatever your compilation unit is. Linting is something that people do a lot. Linting is essentially, whether it's JavaScript linting, make sure whitespace, semicolons and blah, 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 or Java linting, right? Make sure that style formatting is correct. There are people who run tests. I think that is a little excessive. For every commit, they'll run the tests, which is a little excessive. What's that? You could do it before push, yes. Now, we have Jenkins job that verify pull requests and master, so we don't push this, but that's not a bad idea. The trouble is sometimes tests can take too long, and then what ends up happening is if you put it in your pre-commit hook, developers will start making bigger and bigger commits because it's too expensive to make small commits. So don't think of the cost of these. There's a commit message hook which validates the commit message you are using, and I'll talk about that in a few minutes. And this is AngularJS's hook. This is a link to AngularJS's repository. They have a very, very nice way of validating commit messages. They use Node, but you can write that script in any language you want, that's fine. But very, very nice hook. I actually use those on my repositories. AngularJS's commit message validation. And I'll talk about that in a few minutes. How's everyone doing with hooks? That make sense? You should be using hooks. Don't try and, if you can automate at the Git level, at the CI level, whatever. This is all about automation. Let's talk about the Git log. This is the mantra, right? So many of my talks, I give people affirmations, right? So in the morning when you wake up, you tell yourself, I will make small commits and I will make frequent commits. After lunch, you tell yourself 3 times, I will make small commits and I will make frequent commits. When you go to bed at night, 3 times, I will make small commits, I will make frequent commits. If you know how to rebase, if you know how to stash, you shouldn't be making big chunky commits. Commit on your feature branch as quickly as you can. You can always go back and clean stuff up, right? We saw that in Rebase Interactive, right? Quick, fast commits. Each commit should be atomic in the sense that it should make sense in and of itself. Don't like half compile or broken compiled code into a commit. You should commit fast, commit often, and you can always use Rebase to fix commits prior to publishing. What that means is prior to pushing upstream. Be consistent in commit messages. I'll talk about this in a second. Use the Git Commit hooks or the Git pre-message hooks to validate your commit messages. Now this is me getting all preachy. If you don't like people getting on a soapbox, you can leave now. Thank you for coming in. A commit message, this is the guidelines the Linux team has established, one that I enforce, but so far have not been very successful. So I'm hoping you guys take this message to your companies and sell it to your developers. A commit message is like an email. It has a short title or a subject which has to be less than 50 characters. If your editor does not tell you a count of edit characters on a line, what are you going to do? Find a new editor. Very good. It is followed by a longer description that has to wrap at 72 characters. This is a hard wrap. You're going to hit a return when you hit 72 characters. Here's a typical format. This is the one Angular uses. This is the one I prefer to use. There is a type tag colon space the subject of the email or the subject of the commit. So feature colon added new button, refactor colon fixed implementation, something like that. Blank line, the body which wraps at 72 characters, blank line, some footer. Let me show you a quick snippet here. Here are the tags that I prefer. This is from the Angular project. You can use one. So this type can be one of feature, fix, doc, style, refactor, test, chore, or revert. Can be one of those. So you say feature colon subject body. This entire string cannot cross 50 characters. You have to be very, very succinct. So in this case, I'm saying commit header should have a valid type. Total length 50 characters. Does that make sense? This is the body. Again, at this point, I might have hit 69 or 70 characters. Hard return is a new line. Hard return to this. If you have multiple paragraphs, delimit them by blank lines. And in the footer, if you use something like Gerrit, or you use, anyone use Jira? Okay. Does anyone know what a smart commit is? If you put a footer in your commit, if your Git repository is tied with Jira and you put something like JRA-ID #close, it will close the associated Jira ticket on the other side. Very, very nice. So that's the footer. This is get it if you are using get it for code reviews. So here's a full blown example. This is how your commit should look. Subject body is 50 characters followed by the pretext. 72 characters, so blank line, 72 characters wrap, 72 characters wrap, blank line, 72 characters wrap, blank line, footer. This is how a commit message should look. This is part of how Linux team does their commit messages. This is the reason why Linus went on a rant on GitHub, but why no one should be using GitHub's UI to write commit messages. Because they don't tell you when you cross 72 characters. It's a text area. You type, that line could be 400 characters long. They don't wrap. This is why he went on a rant. The reason for that is multifold, but if you look at Git log, if you look at source tree, by default, this width will show you 50 characters. So when I'm looking at the log, this is source tree by the way, I can read everything without seeing that. What is ellipsis? Is that what it's called? Dot, 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 or whatever crap they put in UIs these days. I can read what the commits are. The second thing this buys you is if I know what is a feature versus what is documentation versus what is refactor, I can auto-gen a change log. You never have to publish what changed in version 1 to 2. You can auto-generate this. This is what we do. We auto-gen the change log. This is what Angular team does. We auto-gen the change log. Yes, sir.
So do you have a regex that you use to check that?
We have a JavaScript script, but it uses regular expressions. Yes. The other thing, anyone use Git bisect? Good. This is where big Git bisect will come useful. If I know something is a documentation commit, do I care in the bisect? No. It's not going to change the logic. There's no way to introduce a bug. Skip right over it. We don't have time to talk about Git bisect, but it's one of the coolest things in Git. But this helps, right? This is how your commit messages should be. And you can use the Git Commit Hook to check for this. If you look at the AngularJS hook, that's what they do. Is the hook checks and makes sure type can be one of 8 types, colon, space, message, less than 50 characters, blah, 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 blah. All of that is checked as part of the pre-commit hook.
And then so if the hook fails, the commit is stopped in its tracks?
Correct. You cannot commit if you can't pass the hook. There is a way to bypass the hook, but I'm not going to tell you that. How's everyone feeling so far? Think this was useful? All right. Well, 1 minute to go. I'm here for questions. I know I have to take care of the TFS thing and somebody else has a question. Okay. Come up front. Thank you all for coming in. Enjoy lunch. Enjoy the rest of the conference. Thank you.